Welcome to Morrison Uncovered. My name is Nova, I'm your presenter, and this is the series where we discover the secrets of Jurassic North America. In this first episode, we will lay the groundwork of what is to come and talk about the geography, geology, and general environment of the Morrison Formation. For us to understand the great Jurassic dinosaurs, we need to understand where they lived first. We begin our journey through time and space in the late Oxfordian stage of the Jurassic, roughly 156 million years ago. Here's where the Morrison Formation begins, yet it is quite far from what one may imagine. This is called the Tidwell Member, the oldest of the formation. During this time, the Rocky Mountains had just begun forming, being slowly pushed up by colliding continental plates. Due to this, a great inland sea, called the Sunland Sea, that had covered much of North America until then, was slowly beginning to recede northward. In this coastal new land, many dinosaurs must have surely lived, yet we only know of a single one. Said dinosaur was Dystrophaeus, a comparatively small sauropod, and a rather mysterious one at that. We only have scraps of limb bones and tail vertebrae of it, with scientists debating for centuries now on where Dystrophaeus belongs in the sauropod family tree. Only a very recent study by Foster et al. In 2026 started to clear some of this mystery up, uncovering that Dystrophaeus was, at the very least, not one of the latest so diverse diplodocids. What exactly it was is still unknown, as is much of the dawn of the Morrison. We move on a few million years into the early Cambrian to the Saltwash Member, the next large member of the Morrison. The Rockies are pushing up more and vast coastal washes cover the land. This time is also when the classic Morrison fauna begins to take shape. The oldest species of allosaurs, the smaller A. jamatsoni, which you may know from the famous Big Owl specimen, was discovered here. Also found is the iconic apatosaurian sauropod Brontosaurus. In general, the animals here are somewhat smaller than in the later Morrison, as well as still being a bit more coastal. From the later Cambrian into the early Tithonian then spans the most fossil-rich and latest of the Morrison members, the Brushy Basin member. This is what is so often seen in documentaries, books and movies, and is also where the 3D reconstructions of this here project are set. The Sunland Sea has virtually disappeared, leaving behind massive salt flats and lakes. Winding rivers meander through the landscapes, and volcanoes belch towards the west, where the Rocky Mountains are still in their infancy. These rivers and volcanoes are still what mark the Morrison to this day, with most of its rock being made up of mudstones and ash. In this mudstone deposit, especially around the Colorado Plateau to the south, is where the vast majority of fossils are found, usually consisting of ancient oxbow lake deposits, streams and river bends. This southern area is also where the Morrison was driest, with ferns and horsetail covered prairies stretching across the land. Interestingly, unlike how a lot of media depicts it, no true deserts were found here, with plenty of ground being vegetated and even forested. A good analogue may be the African Serengeti, with a bit of American redwood sprinkled in. Let's then take a step closer and look into these environments, beginning with the forests. The trees here, primarily consisting of the giant Brachyphyllum and Araucaria relatives, can get to over 70 meters tall, only matched by modern redwoods. Within these mosaics of clearings and denser forests is where we find both a variety of tiny animals like the theropods, Ornitholestes and Silurus, multituberculate mammals or early ankylosaurs, as well as true titans such as Brachiosaurus. We have found little tooth wear on the teeth of Brachiosaurus, indicating them preferring tall plants far off the ground. Truly the giraffes of the Jurassic period. Found primarily within forested streambeds, so likely living also within the woodlands as well, are the predators Torvosaurus and Ceratosaurus. Analyses of the dry mesa quarry fauna by Foster et al. Once again suggests that, along with their usual terrestrial prey, these two theropods may have also consumed aquatic prey from time to time. This could have included the variety of lung and bony finned fish, as well as plenty of turtles and crocodilians also found in the area. Slowly moving into more open land, we can see small pterosaurs fluttering through the air. While species up to the size of an eagle exist in this ecosystem, this Mesodactylus here is more comparable to a bat in size and ecological role. Much larger than is the Camarasaurus, the most common sauropod of the Morrison. Being true generalists, they can be found all throughout both woodlands and prairies, migrating constantly in search of food. Smaller predators take advantage of the migrating herds, such as the brightly colored Marsosaurus here picking off the small land croc-footed Champsa, or the much bigger Taurosaurus waiting farther away. Mingling with the herds are also many ornithopod dinosaurs, such as the deer-sized Dryosaurus, Buffalo-sized Camptosaurus, or the smaller Euterodon, pictured here, only about the size of a pony. They are, however, not the only smaller herbivores commonly found in the Morrison, as young sauropods make up a huge amount of the small plant eaters. Due to their enormous adult size, sauropods could not directly care for their minuscule young. So instead, akin to modern sea turtles, they laid dozens of eggs, so that at least some of their young could make it to a size at which they can join the herds. This means that most sauropods at any given time were actually quite small, leading to them being a cornerstone of the local predatory food web. These sauropodlets are only rarely found by paleontologists today, yet it can be presumed that they mainly frequented the denser forests and woodland mosaics until they reached a size at which they could enter the open plains. Sedfern prairies were grassless open lands dominated by horsetails, Psychodoidea, ferns and sparse trees. This is where one may find the majority of the sauropods, especially the vast variety of flagellar chordatans. Diplodocus, Apatosaurus, Barosaurus, Cartodocus, Galeomopus, and many others may be found here, along with the massive Thyreophorus, Stegosaurus, and the most commonly found predator, Allosaurus. This is by far the most vast environment of the Morrison, stretching away like today's African savannas. This comparison also extends to the weather and climate, which fluctuated between torrential rain during the wet seasons and blistering heat during the long dry season. Great seasonal change like this is the catalyst of why the Morrison Formation has such a huge amount of fossil deposition. Once an animal dies in the dry season, it may desecrate, drying out and preserving its bones. Then, when the flood of the wet season arrives, the carcass gets buried quickly, leaving it ready to be fossilized over the next 150 million years. How then did the Morrison Formation come to an end? Well, towards the later part of the Brushy Basin Member, going into the early Tithonian, we notice an interesting trend. Animals get massive. These later stages are where we find the largest species of Camarasaurs, large Apatosaurus individuals, the remains of the largest known Allosaurs, or Saurophaganax depending on your views, as well as Supersaurus, the most enormous confirmed sauropod of the Morrison, perhaps even the entire Jurassic period as a whole. And then, nothing. A gap in the geological record opens up at around 148 million years ago, with it only continuing several million years later in the Cedar Mountain Formation, where there are no more Diplodocus, Megalosaurids, Stegosaurids, and instead we suddenly have a diversity of iguanodontids, polycanthid, ankylosaurs, turriosaur sauropods, and giant dromaeosaurs, such as the famous Utahraptor. Well, there are certain theories of what may have happened to cause this end Jurassic extinction event, like a possible meteorite impact or volcanic activity. What may have ultimately happened is still a mystery. If you are interested in this strange extinction, I can only recommend watching Jim Kirkland's talk Dino Decimation, which is where I have a lot of my info for this video from. It is free to watch here on YouTube, and I can highly recommend it. With that, this first episode of Morrison Uncovered comes to an end. I hope you have enjoyed this entry look into the most fascinating environment, and I, at least, am quite excited for what is to come. If you are too, please consider subscribing to my channel and liking the video. It would be very much appreciated. And please, have a nice rest of your day. Goodbye!